Engineers heard something they should never have heard, a faint but violent hiss deep inside Glen Canyon Dam. It was the sound of supercharged bubbles, tiny vapor spheres exploding, ripping apart steel and concrete. This was a really bad sign. As of July 16, 2026, Lake Powell's water level was at 3,523.84 feet. That's barely 34 feet above the point of no return. Below that line, the dam's plumbing starts to destroy itself. And if it fails, 40 million people across 7 states lose their water supply, not a little less, but completely gone. This isn't just about an empty lake, it's about a broken dam, and we're watching it happen right now. The whole system is like a chain reaction. You have Lake Powell, the upstream battery, feeding Lake Mead, the downstream engine. Together, they make up the biggest water storage system in the U.S. Glen Canyon Dam, this huge concrete wall, was finished in 1963. It was built for a perfect world. A climate that wasn't too wet or too dry. A river that always behaved. And for a while, it did. The Colorado River filled up behind it, creating Lake Powell, a huge blue lake in Utah and Arizona's Red Canyons. Downstream, Hoover Dam held back Lake Mead, providing water for places like Las Vegas, Phoenix, and Los Angeles. These two reservoirs were an amazing interconnected system, built to last centuries. But there was a fundamental flaw from the start. The big mistake for the Colorado River happened back in 1922. That year, the 7 states in the basin signed an agreement, the Colorado River Compact, that divided the river's water based on measurements from an unusually wet period. Now, hydrologists know those numbers were just wrong. The compact promised more water than the river actually provides in an average year, creating a problem right from day one. For decades, that problem was hidden because the reservoirs were so big. The system was running in a quiet deficit. Every year, the lower basin states, California, Arizona, and Nevada, used their full share, plus another 1.5 million acre-feet that simply evaporated or was lost, which nature never replaced. To put it simply, that's 489 billion gallons of water. It was like paying debt by draining your savings account, the reservoirs. For the last 20 years, people have watched the bathtub rings grow around Lake Powell and Lake Mead. Those white lines on the canyon walls became a symbol of the megadrought, a permanent scar showing how much water was gone. The story seemed simple. The lakes were shrinking. The crisis was easy to see. But while everyone was looking at the surface, the engineers at the Bureau of Reclamation were looking at the dam's blueprints, absolutely terrified about an issue deep underwater. They knew the worst-case scenario for the Colorado River wasn't a dry lake bed. It was a plumbing failure. Glen Canyon Dam could release water in 2 ways. The main way is through 8 huge pipes that feed the dam's hydroelectric turbines. Water flows through them, spins the turbines for power, and then goes downstream toward Lake Mead. That's how it's supposed to work. But these pipes have a big flaw. They're at a certain height in the dam. If the lake level drops too low, below 3,490 feet, they can't draw water anymore. That's called minimum power pool. Below that, the dam stops producing electricity. The only way to get water out then is through the backup system, a system that was never designed for this kind of crisis. They're called the River Outlet Works. These are 4 steel tubes, just 8 feet wide, drilled through the base of the dam near the original riverbed. They were built for temporary use, like managing floods or bypassing the turbines during maintenance. They were absolutely not built to run the entire Colorado River non-stop for months or even years. And running them at low lake levels triggers something truly awful for physicists: cavitation. When water moves super fast through a pipe where the pressure is low, tiny vapor pockets form in the water. When these bubbles hit an area of higher pressure, they collapse. They literally implode. The force of each implosion is tiny, but when you have millions of them, it's relentless. Millions of these supercharged bubbles basically act like tiny jackhammers against the pipe walls, eating away at solid steel and concrete. It's water turning into a weapon against its own container. The sound is a high-pitched hiss, signaling that the material is being torn to pieces. Engineers know this problem really well. It's one of the most destructive forces in fluid dynamics. And they've seen it before, right here at this dam. Back in May 1983, the opposite problem happened. A massive El Niño winter brought crazy amounts of snow to the Rockies. The spring runoff was biblical. Lake Powell filled up completely and kept rising. The reservoir was about to overflow the dam itself, which would have been an unimaginable disaster. To save the dam, engineers had to open its two huge spillway tunnels, concrete chutes designed to handle extreme floods. They had never been tested at this level. The sheer volume and speed of the water rushing through the spillways over 150 miles an hour immediately caused severe cavitation. Those supercharged bubbles started to rip apart the 3-foot-thick reinforced concrete lining of the tunnels as if it were drywall. Divers who inspected the damage after the flood found craters the size of houses gouged out of the concrete. The dam came incredibly close to a total structural failure. It almost destroyed itself from having too much water. The irony is just brutal. Now, 43 years later, the Bureau of Reclamation could lose the dam to the exact same physics, but this time because of too little water. A March 2024 internal memo from the Bureau of Reclamation confirmed what experts had feared for a long time. The river outlet works, those 4 bypass tubes, already showed signs of cavitation damage from being used off and on. The memo clearly warned that you couldn't rely on these tubes for sustained, long-term water delivery. Running them continuously at low lake levels would be a huge risk to the dam's integrity. If those tubes vibrate, erode, and fail, they could collapse or get clogged. That would create a structural dead pool. Millions of acre-feet of water would be stuck in Lake Powell, a huge, useless lake behind a 710-foot concrete wall, while the Colorado River downstream, the water supply for Lake Mead, Las Vegas, Phoenix, Los Angeles, and millions of acres of farmland would just dry up. Instantly, the crisis hit right on schedule. The winter of 2025-2026 was terrible. Snowpack in the upper basin was frighteningly low. Then, a record-breaking heat wave in March 2026 melted what little snow there was way too early. The runoff was just a trickle. Lake Powell's level started dropping toward the 3,490-foot line at an alarming speed. The abstract fear engineers had was about to become real. On April 17, 2026, the federal government, under Interior Secretary Doug Burgum, declared a formal emergency. Acting Reclamation Commissioner David Palumbo issued the order. They had to save Lake Powell. They had to keep the water level above 3,490 feet no matter what. Their solution was an act of brutal hydrological triage. They decided to sacrifice the patient downstream to save the one currently on the operating table. The plan was incredibly bold. The execution was unforgiving. First, they ordered emergency releases from upstream reservoirs, draining up to 1 million acre-feet from Flaming Gorge on the Wyoming-Utah border to boost Powell. It was a temporary fix, borrowing from one shrinking savings account to patch another. But the second part of the order was the real shocker. The federal government unilaterally cut the amount of water released from Lake Powell to Lake Mead each year. The legal requirement under the 2007 interim guidelines was 7.48 million acre-feet per year. The emergency order cut that to just 6.0 million acre-feet through September 2026. That's a reduction of almost 1.5 million acre-feet. It's an amount of water so huge it could supply the entire state of Nevada for 5 years. Gone, withheld, kept behind Glen Canyon Dam to keep its turbines working and its bypass tubes silent. It was an unprecedented move. Xana Stutz, a program director at the Glen Canyon Institute, called it what it was: reservoir triage, a desperate, short-term fix for a problem that needed a long-term solution. Jack Schmidt, the respected head of the Center for Colorado River Studies, put it more simply: reservoirs are bathtubs, and it's hard to refill them if the drains remain wide open. The federal government had just slammed the drain plug on Lake Powell, but in doing so, they practically pulled the plug on Lake Mead. The effects of this decision are impacting the system right now. Every drop of water held back at Powell means a drop that never reaches Mead, and Lake Mead was already in terrible shape. Today, its elevation is around 1,050 feet. Projections from the Bureau of Reclamation's own studies show it will hit all-time record lows in the next 2 years, a direct result of that April 17th order. The public just sees another falling lake. Power grid operators, though, see something very specific: a cliff. The critical number for Hoover Dam is 1,035 feet. That's the power cliff. While Hoover Dam can technically produce some power all the way down to 950 feet, at 1,035 feet, its efficiency just falls off a cliff. Below that, 12 of its 17 massive turbines start to lose their ability to generate power effectively. The water flow changes, the pressure drops, and the power output plummets. The emergency action to save Lake Powell basically guaranteed that Lake Mead will fall below this cliff. The Bureau of Reclamation's press release was blunt. It warned of a potential 40% reduction in Hoover Dam's hydropower output by the fall of 2026. 40%. That's not just a flicker. That's a regional brownout affecting an electrical grid that serves millions in Arizona, Nevada, and Southern California. The cost of saving Glen Canyon Dam's turbines is losing Hoover Dam's power generation. One dam's plumbing problem becomes another dam's power crisis. The price of preventing a catastrophic infrastructure failure at Powell is a guaranteed energy crisis at Mead. It's a chain reaction, a domino effect created by the federal government itself out of pure desperation. They're choosing the lesser of two terrible scenarios. But here's what they didn't really tell you. Not everyone will suffer equally. While farmers in Arizona and California watch their water disappear and the lights flicker in Phoenix, one city will be surprisingly okay. Las Vegas is looking at the same draining lake, drawing from the same dying river. But they planned for the end of the world. For years, the Southern Nevada Water Authority, the agency that keeps Las Vegas running, watched the lake levels drop and understood that their intake pipes were incredibly vulnerable. Their first two intake pipes, built in 1971 and 2000, would be useless if the lake dropped too low. So, they took a desperate, almost impossible $1.5 billion gamble. They built the third straw. It's not just another pipe. It's an engineering marvel with huge implications. It's a 3-mile-long tunnel drilled through solid rock deep under Lake Mead itself, connecting to an intake structure at 860 feet. That's 35 feet below the dead pool level. It's basically a straw drilled into the very bottom of the lake. Even if Lake Mead drops so low that not a single drop of water can flow past Hoover Dam to California or Arizona, even if the dam's turbines stop forever, Las Vegas can still pump water. They essentially drilled their own private escape hatch at the bottom of the bathtub. The $1.5 billion project, paid for by the people of Southern Nevada, ensures that when the river truly dies, the casinos, the fountains, and the faucets of Las Vegas will be the last to know. This engineering foresight creates a brutal political reality. While the agricultural heartland of the Imperial Valley faces ruin, and cities like Los Angeles and San Diego face severe cuts, Las Vegas has a lifeboat. It completely changes the dynamic of the negotiations, which are failing spectacularly right now. The legal framework that has governed the river for 20 years. The 2007 interim guidelines ends on December 31st, 2026. That's a hard deadline. As of today, the 7 basin states are completely stuck. The upper basin states, Colorado, Wyoming, Utah, and New Mexico, argue that the lower basin has been using too much water for a century and needs to take permanent cuts. The lower basin states, especially California with its older water rights, refuse to give up what they see as legally theirs. Everyone is looking at a shrinking pie, and no one wants a smaller piece. So, the federal government, led by Secretary Burgum, is being forced to consider a drastic step, imposing a federal solution if the states can't agree. This would mean federally mandated cuts of a huge scale, overriding a century of state-level agreements. The political backlash would be enormous. Lawsuits would fly. The conflict would reshape water law in the American West for the next century. This political gridlock is happening while the physical crisis gets worse and worse. Engineers can't wait for politicians to agree. The dam won't wait. The cavitation won't wait. The problem isn't abstract anymore. It's real. The dam is speaking. That quiet, violent hiss of those supercharged bubbles is a countdown clock. Some engineers have suggested an even more radical plan to get around this problem. A multi-billion-dollar project to drill entirely new tunnels, massive bypasses through the solid sandstone bedrock under Glen Canyon Dam, designed to safely pass water at river level no matter how low the reservoir gets. It's a monumental undertaking that would cost billions and take at least a decade to complete. A decade the river might not have. It's a solution for a problem that was never supposed to exist, for a dam built for a world that simply isn't here anymore. The real question, the one being quietly discussed inside the Bureau of Reclamation, isn't about saving the system anymore. It's about managing its inevitable collapse. Was sacrificing Lake Mead to save Lake Powell the right choice? Or did it just delay a failure at one dam by guaranteeing a crisis at another? They've chosen to protect the physical integrity of the upstream infrastructure over the overall operational capacity of the entire system. They're betting that a power crisis is easier to deal with than a total water cutoff. But the physics of the river are tough. That structural deficit of 1.5 million acre-feet a year is a mathematical fact. The rising temperatures and shrinking snowpack are a climate fact. And those imploding bubbles tearing up the steel liners of the river outlet works are a hydraulic fact. You can't negotiate with cavitation. You can't pass a law to fix fluid dynamics. The crisis on the Colorado River was never just about not enough water. It was about too many assumptions. The assumption that the climate was stable. The assumption that the river would always provide. The assumption that the concrete would hold. Every single one of those assumptions has been proven wrong. The engineers who built Glen Canyon Dam designed it for a perfect world. They didn't design it for this one. They didn't design it for a 25-year mega drought. They didn't design it to run on its emergency backup systems for months on end. They didn't design it to basically eat itself alive from the inside out. The system is operating way beyond its original design, in a constant state of emergency. And somewhere, deep inside 7.5 million tons of concrete, a faint vibration continues, a sound that warns of a failure that won't be slow